Hello students, in my previous video I have done up to 6E and in this session I am going to discuss about sums of 6F which are mainly based on converse of Pythagoras theorem. Here question number 1 is the sides of certain triangles are as given below. Determine which of them are right angled triangle. In first part of question number 1 it is given A equals to 3 cm, B equal to 4 cm and C equal to 7 cm, and we have to check whether using these sides a right angle triangle can be formed or not. Out of these three, A and B are smaller sides, so we will take the sum of the squares of these two. So it is A square plus B square. So A square is 3 square plus 4 square. 3 square is 9 and 4 square is 16. If I add, it will be 25 centimeter square. Again, out of these three, longest side is C, which is 7 centimeter. So now I will calculate C square. So if I take C square, then C square equal to 7 square. 7 square is 49 centimeter square. So A square plus B square we got 25 centimeter square and C square is 49 centimeter square, which are not equal. So from converse of Pythagoras theorem, given sides cannot form right angled triangle. In second part of question number 1, it is given A equal to 9 cm, B equal to 16 cm and C is 18 cm. Here out of these three, A and B are smaller sides and C is the longest side. So first we will take the sum of the squares of smaller sides. Smaller sides are 9 and 16. So it will be A square plus B square, that is 9 square plus 16 square. 9 square is 81, 16 square is 256. If I add, I am going to get 337 centimeter square. Again, out of these three, 18 is the longest side. If we take the square of the longest side, it will be 18 square, and 18 square is 324 centimeter square. So A square plus B square, which is 337 centimeter square, is not equals to 324 centimeter square. Therefore, A square plus B square is not equal to C square. So from converse of Pythagoras theorem, given sides cannot form right angled triangle. In third part of question number 1, it is given A is 7 cm, B is 24 cm and C is 25 cm. Here also out of these three, A and B are smaller sides and C is the longest side. So first we are going to calculate sum of the squares of smaller sides. So 7 square plus 24 square, 7 square is 49, 24 square is 576. If I add these two, then it will be 625 centimeter square. Again, here longest side is C, which is 25 centimeter. So C square is 25 square and 25 square is 625 centimeter square. Therefore, A square plus B square is C square. So from converse of Pythagoras theorem, the given sides can form a right angled triangle. In number 4, it is given A is 1.6 centimeter, B is 3.8 centimeter and C is 4 centimeter. Here out of these three, A and B, these are smaller sides. So A square plus B square, it will be 1.6 square plus 3.8 square. 1.6 square is 2.56 and 3.8 square is 14.44. If I add, it will be 17 centimeter square. Now if I take the longest side, which is 4 centimeter, C square is 4 square and 4 square is 16 centimeter square. So in the first case we got 17 and second case we got 16. Therefore, A square plus B square is not equal to C square. So from converse of Pythagoras theorem, the given sides cannot form a right angled triangle. In the last part of question number 1, it is given A1 is A minus 1 centimeter, B1 is 2 root over A centimeter and C1 is A plus 1 centimeter. So we got A1, B1, C1. Now out of these three, C1 is the longest side. So we will consider A1 and B1. So A1 square plus B1 square, it will be A minus 1 whole square plus B1 is 2 root over A, so 2 root over A whole square. We are just taking the sum of the squares of smaller two sides. So here A minus B whole square, it will be A square minus twice AB plus B square. 1 square is 1 plus 2 square is 4 and root A square is A. So A square minus 2A plus 1 plus 4A. So A square, 4A minus twice A is plus twice A plus 1. Again, if I take C1 square, C1 we have considered A plus 1. So A plus 1 whole square is A square plus twice AB plus B square. So it is A square plus twice A into 1, it will be twice A plus 1. So here also we got a square plus twice a plus 1. Here also a square plus twice a plus 1. So we can write a1 square plus b1 square equal to c1 square. So from converse of Pythagoras theorem, the given sides can form a right angled triangle. In question number 2, it is given that a man goes 15 meter due west and then 8 meter due north. How far is he from the starting point? Suppose A is the starting point. The man moved 15 meter towards west, then he moved 8 meter towards north, and C is the final position. Now here AB is 15 meter, BC is 8 meter. AB is 15, BC is 5, and angle ABC is 90 degree. Since this is 90 degree and we have to find AC, so we have to join AC. So in the construction section I have written AC is joined. Now in right angle triangle ABC, since this angle is 90 degree, so AC square is AB square plus BC square. So here I have written AC square is AB square plus BC square by Pythagoras theorem. Now AC we have to calculate. AB is 15, BC is 8, so it will be 15 square plus 8 square. AC square is 225 plus 64. 8 square is 64. 15 square is 225. If I add, then I am going to get AC square equal to 289. 289 is the square of 17. So AC is 17. Therefore, the man is at a distance of 17 meter from the starting point. In question number 3, it is given that triangle ABC is an isosceles triangle with AB equal to AC equal to 13 centimeter. The length of the altitude from A to BC is 5 centimeter. We have to find the length of BC. Now here ABC is an isosceles triangle because in this triangle ABC, AB equal to AC equal to 13 centimeter. AD is drawn perpendicular to BC and AD is 5 centimeter. Now we have to find the length of BC. Now since this is right angle triangle, in triangle ADC, here angle ADC equal to 90 degree. So if I apply Pythagoras theorem, then it will be AC square is AD square plus CD square. So we can write AC square equal to AD square plus CD square by using Pythagoras theorem. Now here AC is 13, AD is 5, but CD is not known. So we can write 13 square equals to 5 square plus DC square. 13 square is 169, 5 square is 25 plus DC square. 169 minus 25 is DC square. If I subtract, it will be 144 is DC square. So DC is root over 144. Therefore DC equals to 12 centimeter because 12 square is 144. So we got DC as 12 centimeter. In this triangle also this is 13, this is 5. So similarly BD also will be 12 centimeter. Therefore we can write similarly BD equals to 12 centimeter. Therefore BC equals to BD plus DC. Both of them are 12. So 12 plus 12, 24. Therefore 24 centimeter is the required length of BC. In question number 4, it is given in the figure O is a point inside the triangle PQR such that angle POR is 90 degree. OP is given 6 centimeter, OR is 8 centimeter. If PQ equals to 24 centimeter, QR is 26 centimeter, then we have to prove that angle PQR is right angled. Now as given in the question, angle POR is right angled. So we can use Pythagoras theorem in triangle POR. Since this is 90 degree, so we can write in triangle POR, angle POR is 90 degree. So PR square, because PR is the hypotenuse, PR square will be PO square plus OR square. So PR square is PO square plus OR square. PO is 6, OR is 8, 6 square is 36, 8 square 64. If I add, it will be 100, and therefore PR square is 100. So PR will be root over 100, which is 10 centimeters. So in triangle POR, this one is 6, this one is 8, this part PR we got 10 centimeters. Clear? Now in the bigger triangle, that is PQR, in case of PQR, this part is given 24, this part we got 10, and this one is 26, and we have to check whether this is a right angle triangle or not. So in this triangle, PQ square plus PR square, because out of these three, these two are the smaller sides. So PQ square plus PR square, it will be 24 square plus 10 square. 24 square is 576 plus 100, which will give 676 centimeter square. Again, QR square, QR is 26, so QR square will be 26 square, which will be 676. So PQ square plus PR square is also 676, QR square is also 676. So we can write PQ square plus PR square is QR square. So from converse of Pythagoras theorem, triangle PQR is right angled. In question number 5, it is given that in an equilateral triangle ABC, AD is perpendicular to BC. Prove that AD square equals to 3BD square. Suppose ABC is the equilateral triangle in which AD is perpendicular to BC. Now we know in an equilateral triangle, perpendicular drawn from the vertex to the base bisects the base. Since AD is perpendicular to BC, so BD equals to DC equal to BC by 2. This BD will be equal to DC equal to BC by 2. Now angle ADB, this angle is 90 degree, so we can use Pythagoras theorem. So if I apply Pythagoras theorem in this triangle ADB, and here this is 90, so this part will be the hypotenuse. So from Pythagoras theorem it will be AB square is AD square plus BD square. So here AB square is AD square plus BD square. Now AB and BC both are equal because it is an equilateral triangle. So AB, BC and AC all are of equal length. So instead of AB I can write BC. So instead of AB square we can write BC square equals to AD square plus BD square. Now BC square equals to AD square plus BD square. Now BC is twice of BD. From this line BC is twice BD. So instead of BC square we can write 2BD square equal to AD square plus BD square. Now 2 square is 4. 4BD square is AD square plus BD square. 4BD square minus BD square equal to AD square. 4BD square minus BD square is 3BD square is AD square. So we got AD square equal to 3BD square. This is what we have to prove. In question number 6 it is given triangle ABC is an isosceles triangle with AC equals to BC. If AB square equals to 2AC square, prove that triangle ABC is right angled. So in triangle ABC it is given that AC equals to BC and AB square is 2AC square. These two are given in the question and we have to show that triangle ABC is right angled. Now as given in the question, AB square is 2AC square. So we can write in the proof part, AB square is 2AC square. So AB square equal to AC square plus AC square. So instead of 2AC square, we can write AC square plus AC square. Again, in the question, it is given that AC equal to BC. So instead of AC, I can write BC. So it will be AB square equal to AC square plus BC square. AB square is AC square plus BC square. So from converse of Pythagoras theorem, we can write triangle ABC is a right angled triangle. I hope this sum is clear and this is the last sum from chapter 6. So that's all for today. In the next video, I'm going to show sums of chapter 7. Till then, bye bye, take care and wait for the next part.